Hello, students. We are going to start our new chapter, chapter number 4, energy. And energy is defined as we say that energy is the capacity to do work. So, before studying energy, it is very important to clear all concepts of work first. In our daily life, we perform physical and mental activities like reading a book. We consider it to be a work. But scientifically, work is said to be done by a force when it displaces a body on which it acts in its own direction, which means work is said to be done only if displacement in the body takes place. If there is no displacement taking place, all the force is applied on the body, work done is said to be zero. Suppose a force F applied on a body displaces it through a distance s in its direction. The work done W is the product of force applied and displacement. Mathematically, it is expressed as W is equal to F into S, which means that work done is the product of force applied and displacement. So one thing important here, work done will be equal to 0 if either the force applied or displacement is A0. So there are two conditions which must be fulfilled for work to be done. And those are, first, a force must be applied. Second, the body should move in the direction of force applied. That is, there should be a displacement taking place in the body. Work is also said to be done on a body if the force acting on it changes its position, shape, speed, or direction of motion. Let us look at some examples of work. Number 1. A coolie standing and carrying a load. When a coolie stands and carrying a load, although he might spend some of his energy, but there is no displacement taking place, hence no work done. Example number 2. A boy pushing a rock. When a boy pushes a rock, the displacement of the rock does not take place, although some force is acting on it, so no work done in this case. Example number 3. While reading a book. When we are reading a book, there is no force applied as well as there is no displacement takes place. Hence we say that there is no work done in this case. Example number 4. Lifting the books from the ground. When someone lifts the books from the ground, some force acts here as well as the displacement also occurs in the body. So work is done in this case. While playing football or cricket etc. or climbing up the stairs, we say that work is done here as there is force applying, also displacement takes place in these procedures. Also work is done in changing the shape and size of a rubber ball when we squeeze it in this manner on applying some force. Let's talk about units of work. The SI unit of work is joule. It is written as capital J. Capital J is the notation for joule. 1 joule is equal to 1 Newton into 1 meter. As work done is equal to force into distance as we've discussed earlier, and since SI unit of force is Newton and SI unit of distance is meter, and hence the SI unit of work done becomes Newton meter, which is written as joule, which is represented as capital J. 1 joule can be defined as the amount of work done when a force of 1 Newton moves an object by 1 meter in its direction. Now we will study about energy. As we defined the energy earlier, it is the capacity to do work. Therefore, more the energy possessed by the body, greater is its capacity to do work. Which means that if you have more energy, you have more capacity to do work. Let's look two cases that arises from here. First case, when work is done by a body, energy is spent. Which means that when you do some work, energy is spent from your body. Let us look at the examples. Example number 1. When you run for some time, you do work and energy is spent. Example number 2. When you play football or cricket, you run all over the field and spend energy in doing that work. You will be able to continue to play football till you possess some energy in your body. Case number 2 is when work is done on a body, it increases the energy of the body. Let's understand this with the help of an example. When a boy kicks a ball on the floor, the ball starts moving. This is because the work done on the ball gives the energy to the ball to move on the floor. This means work is done on the ball, due to which ball gains some energy and hence it starts moving on the floor. Now let's talk about unit of energy. Well, unit of energy is same as that of work. Since the SI unit of work done is joule, that is capital J, so unit of energy is also joule. Now in the previous class, you must have studied different forms of energy like sound energy, electrical energy, chemical energy, etc. And one of those is mechanical energy. In this standard, we are gonna study detailed about mechanical energy and its types. So basically, mechanical energy is defined as the energy possessed by a body due to its position or motion. That is, the energy possessed by a body due to its state of rest or state of motion is called mechanical energy. Well, mechanical energy is found in two forms. That is, there are two types of mechanical energies. First one is kinetic energy and the other one is potential energy. Actually, the total mechanical energy of a body is a sum of its potential and the kinetic energy. Like in these figures, a car in motion, rock on a high hill, etc. all have mechanical energy. Moving on to the first type of mechanical energy, that is kinetic energy. Well, it is the energy possessed by a body by virtue of its motion. That is, the energy of a body in motion is called its kinetic energy. That is, if any body is in motion, then it possesses some energy and that energy is called kinetic energy. Let us look at some of the examples. Number 1, the energy possessed by this moving truck. Since this is moving and hence this possesses some energy and that energy is kinetic energy. Example number 2 is this bike. This bike is moving on the road and it is possessing the energy and that is kinetic energy. Example number 3 is this fast moving ball and this fast moving leopard. Both are in motion and hence they possess some kinetic energy. Similarly, this flowing water as well as this flying bird, both are in motion and hence possess kinetic energy. Factors on which kinetic energy depends. The kinetic energy of a moving body depends on the two following factors. First one is mass of the body. Since kinetic energy is equal to half mv square, where m is the mass of the body and v is the velocity, so kinetic energy becomes directly proportional to the mass of the body. So as mass increases, kinetic energy also increases. So greater the mass of the body, higher is its kinetic energy. For example, in this diagram, the boy is throwing a stone on the window pane. This stone would create a huge loss if the stone would be of higher mass because then it will have greater kinetic energy. Second factor is the speed of the body. More the speed of the body, higher is its kinetic energy. For example, if the boy throws the stone with the higher speed, then it would gain the great kinetic energy and would create a huge loss. So if a body of mass m is moving with a speed v, its kinetic energy is given as half mv square. And the unit of kinetic energy is also joule, that is capital J.